Hi everyone, in this video we will learn about DevOps. It's a very important concept to learn for a developer. A developer should know what is DevOps and why it is being used and why it is the most trending subject nowadays. Okay, so let's start with the term DevOps itself first. What is DevOps? Okay, so we'll see here in DevOps it is made of two words: dev, which is for development, ops for operation. So if I give the explanation, so DevOps is what? Let's not make another box. Let me delete. I'll add in this one only. Okay. So development plus operations. As you are already aware of the terms, what development means to build a website, to create or to write some code to build an application or web application to solve some problem. Okay, for example, we have food restaurant websites, we have library websites, we have YouTube, WhatsApp, Twitter, everything. These all are web applications and application, mobile application, which are being used, right? So to make them work, we write some code in some languages. We can write maybe using Python, Java, and some other things like Kotlin also. So there are many languages available. So this is not the part. Languages are not the part of the discussion, but the development is. So we can write the code in any language, and that code writing is the process of development of developing a program or a web application. You're writing a program, it builds an application, web application, mobile application. Now the second word, which is operations. Operations is nothing but the processes and the steps involved after writing the program, after finishing the web application, right? After writing the code for the web application, what we do? We deploy the application, we monitor the application, we automate some task. For example, reading, writing, uh, the logs, reading the PDF files or saving them in directory, or there are some cron jobs or scheduled tasks which are there. So these are some post operations which are being done by developers. So there are two teams involved here. One is development teams, who are commonly called as developers. They can be Java developers, Python developers, Golang developers, .NET developers, whatever the language they're using. Right. The next thing is the operations. The operations comes in operation teams. Usually we call them, previously before DevOps, we call them admins. So these admins were being responsible for managing the post deployment part. For example, we need to create a server, we need to deploy on server, we need to monitor a server if it is down or up. So all these things were being managed by an admin earlier, before DevOps. But right now what is being done? We have been working with both things together: development plus operation. Both teams work together, or you can say in a team we have a DevOps person also, and the development separately, and operation person also. So they work together, right? So this is DevOps. Now let me introduce you. Let me give you an analogy also. So think of it like a restaurant kitchen where chef is a developer, but the operations, who is doing, who is serving the clients or the customers, that is waiter. So this analogy gives us the complete idea of development plus operations. So the chef is making food. Similarly, the development is creating the or writing the codes to build the web application, and who is delivering it? It is delivered by the uh, waiter, which is in operations. So operation team is uh, responsible for delivering the web applications, right? So this is all about the DevOps. Now the question comes, why DevOps? The second question is, let me remove this. Now the question, it is very important question because we are using DevOps day to day life and it is very helpful. We want to understand why DevOps. So DevOps is necessary. Everyone knows we need to have DevOps person so that we can have the development and operation cycle maintained. So DevOps, the major benefit of DevOps is, let me just tell you the old habits of first. Old ways to deploy. So earlier what we used to do, we used to we used to take more time. So I will give point wise. First point, without DevOps. So what we do without DevOps? Without DevOps, we took more time, or we can say we had separate teams. First thing, this separate teams, separate teams who sit at different places, who are not aligned with or not in a team of development and operations. They were both separate. So this separate team logic were, it was always creating a conflict. It was always creating uh, the confusion that who did what. If something goes wrong, everyone wants to blame other person for the mistake. What happens? Why it happened? So this was the issue with the separate teams. So we had separate teams. So it took, because of this, it takes how much time? Maybe a month or even years to deploy a web application. To deploy a web application, right? Next thing, because the development takes longer time, it takes much more time, so it is relatively slower. And the thing I have already told you, if there is any mistake, if there is any mistake, then they blame someone. It is not ideal to do that, because if you want to work out something, we are building something, we should be aligned, we should be inclined to solution, not the problem part. So DevOps comes into picture for solution part only. So with DevOps, what happened, they have given a way to work, to build, as well as continuously to deploy the application. So this way it was faster, and it has reduced the time to from months to days or even hours. So this part is with DevOps, right? Now here the first point is we had separate teams. Now the teams are working together. Working together. Working together means the developer and the operations both, because it's a DevOps part. Who is developing? Who is the person who is developing? He can also uh, do the deployment. So that's DevOps. It is something like one man army. He is also developing. He is also doing the operations. He's also monitoring. He's also doing the automations, and he's also deploying the applications. Because of this, he had the complete knowledge of the project, what's happening, what is the issue, what was the task, what should be the output, and what can go wrong. So that is the another benefit, because he is working end to end on the web application. So he had idea. If something goes wrong, he can fix it earlier. He can fix it relatively sooner in compared to this part, because the person who is deploying in without DevOps, he does not know, he did not had any idea, he did not have any idea about the code. He can only deploy, and because of this, the applications, whenever application goes down or there is any mistake or there is any error, this web application process goes back and forth. This is an issue, go to the developer has fixed it, go to the admin. So he will deploy, and then again it will send the request if there is any error to the developer about the code. So that's why it took longer. Now they're working together, and DevOps person knows the code as well as the process, as well as the deployment process. So it was very easy to manage and fix issues. Relatively, it is very easy, right? Next thing, application. Now they were working together. What's happening? Okay. Now they work together. Now reduced. Next part is reduced time on deployment, but they can do the frequent deployment also. Frequent deployments, right? So this is the benefit of DevOps. So that's why we use DevOps. We prefer DevOps over individual teams. It is more faster, more reliable, more easier to work with DevOps person rather than different team, right? So now we know what is DevOps and why DevOps. Now we know what is DevOps and why DevOps. So these were the two main introductory part we know, right? Let's move on to the next part. So now we know that DevOps, why do we need DevOps? Now we understand the core principles of DevOps. So let's start with the first core principle. The first core principle is the flow, right? So in flow part, we make work move smoothly from left to right. So it's not like we are writing everything in one go, then deploying everything at the end. It's not like that. So let me just write it down here. So there are three core principles. You can see three core principles of DevOps, right? Okay, so we'll start with first one. First is flow. So what does flow says? Flow says that we are not that we work smoothly, make work move smoothly from left to right. Left to right. What is left to right? Left to right means we start, and while writing the code we also deploy. We do not want to write the complete code in one go. We want to deploy as we are building, and we want to test it, we want to complete the features step by step. So in this part, what we are doing, we are managing the code in batches. So the properties are here. what we do, we write small pieces of code. What does this mean? This means whenever we are writing the code, we are not writing a whole application. For example, if we are building a hospital website, so we do not build everything. Like there are sections and reporting section, there are reporting section, operation sections, medicine section, financial section, and there can be some other part also, like parking, which are not hospital work, like parking and handling customers, sanitary and everything. So this is a very big application to build on, but we do not work on everything. We just want to work on single page. For example, we have completed the reporting part first, so we will build it and we will test it and we will deploy it. This small part first. So this way we will have the smaller code to write, smaller code to test, and smaller code to automate, and smaller code to deploy. This way the chances of failure will become less. So that's why flow becomes smoother. Okay, and we never send in this part, in this flow, what we do, we never send the without untested work to the next team, which is next team. What, there are teams involved, while developing any web applications, or for example developers, QA testers, and DevOps, right? So these are the teams involved. So if we pass on anything, we do not want to pass on the wrong application, the wrong part of the program to the next team. So that's why we make sure that we never pass the untested work to the next team, right? Now, third, for a smooth flow, what we can do, we can reduce the manual work. Reduce, we move to automating the repetitive task. So what are repetitive tasks? So repetitive tasks are these: whenever we deploy any application, so we build we do the ambient build, we do the testing, we create var or jar to deploy. So these kind of things are repetitive, and these kind of things are can be handled. These things can be handled very easily with the automation. So we do the automation for these kind of processes, so that our process becomes easier and less prone to failure. Okay, now the second way. What is the second part? Now let's go to the second part. Second part is feedback. Now what does this mean? So feedback, as you know, the word means feedback, continuous feedback for the application. Whenever we are working, we write some code, we test the code, and after testing the code, if there is any problem, we go back to the developer, we write some code again, and we go back to the tester again. He will test it. Once it is passed, once each and every test is passed, then we will move further up on the ladder. That means to the DevOps person who will deploy it, who will monitor it, right? So that's the feedback part. So feedback, what we are doing in feedback, we are creating fast feedback loops until it does not pass the QA or testers. We will not send it to the next person, which is in the first one, right? So in this part, what we have, what we do to manage this, we automate the tests on each and every single code of line, on each and every single change of code that we do. If there is any challenge, we change it. What we change it? We go back to the developer, and developer will do the changes. He'll make it correct. He'll make it working, and after it is working, it will again send it to the QA. Right? Next thing, we do the continuous monitoring. Monitoring is also important. If something fails, we debug, we test it, we check it, what's the issue, and we fix it. We go back to the developer, we fix it, and we deploy it again. Right? We fix it. Let me add one more thing inside this. If anything wrong, we inform the developer immediately. So this is what we are talking about. We are talking about the production server. So you must be aware of production server. So let me give you a little insight of these servers. So first, whenever we start writing the code, so there can be several stages in which our code is being written. So the very first time we have our code in our local machine, which is the local environment. We are writing, we'll do everything in local, and we'll test it. We'll send it to the testing environment, which is test servers, right? We can all call this as staging server also. So let me write it down here. First is local, second is testing or staging, or sometimes we also call it QA, right? And after this, we can have pre-prod. Pre-prod is also staging. We can have production, right? Or before that, let me give you one more part, live like or pre-prod. So you see, whenever we are building any application, we are writing the program, we are not going blindly and sending the code to the production. Sending the code to the production means we are not going live blindly. We do our work many times. It is being tested. First time it is on local, the developer will test it, the QA, then live like product will try to monitor this live like product. Once everything is okay, we'll send it to the production, and in production part means we are live. So in this phase, we just monitor in production phase. So that's what we are talking about. If anything goes wrong in production, we have to inform the developer immediately, right? And one more thing we can do, the feedback. Why do we take feedback? So there is one very important part, very important thing about feedback, that when we get the feedback, we work on it. So feedback are feedbacks are required feedbacks are required for continuous improvement, right? So that's our part, the second feedback part. So this is feedback. Now third core principle of DevOps is continual learning. So when we do the development and we deploy the application, this is a complete path. It's a whole processes. There are processes in between happening. So when this process happens, there can be, we will make mistakes. We do something wrong, we do something right. So in those scenarios, we need not to blame anyone. We have to learn it. We have to learn from our seniors, from our juniors, anyone who is giving us something good about the technology or anything. We should always open to learn. So as we say, no one is perfect, right? So third part is continual continual learning. So you may be noticing that we are doing this session very slowly because it's not an easy topic to understand. It is, for now it looks easy, but gradually as we move forward it will become tough or complicated. It's not tough. I will not say it's not tough. It's complicated, and there are a lot to learn in DevOps. There are many things in DevOps. So it's a ocean of technologies, ocean of commands, of oceans of processes, and ocean of the ways how we can handle a situation. So there is a lot to learn here. So understand the basics first, then we'll move to the advanced step by step, right? So the first thing I was telling you, the continual learning means no one is perfect. We have to learn from our mistakes, learn from the mistakes, and I would say we have to do blameless postmortems. What does this mean? This means we will do the postmortem, we'll check everything, we'll test, we'll learn, we'll research, but we'll not blame anyone for that mistake if anything goes wrong. So we'll run blameless postmortem. Postmortem after every incident. Okay, that's it. Next part. What is this in? What happened if we do this? If we are doing blameless post-mortem, that means if we are doing mistake, if anyone does any mistake, something happened wrong, but this is not intentional, so then if he or she is not blamed, then they will try to improve themselves automatically because they are not in the pressure that someone will say anything to them. So in that case they will do some experiments in terms of improving experiments improving the code part. Experiments are necessary to improve the process and code, to improve the, or we'll say to improve or enhance the program, or enhance the program. So that's why it is necessary. If anyone, so you also understand this, whenever someone tells you that this needs to be done like this way or that way, you will feel stuck, or you will feel that why I'm even trying to do that. So in that case we should have give the leverage, we should give the benefit of doubt, so that the the candidate or the employee can work without any pressure, that if something goes wrong they can work freely. Their mistakes can be treated as the learning opportunities, but not the punishment opportunities. So that's what I'm trying to tell you here. Next thing, whenever anything happen or nothing happen, we always share the information within the team. Share the knowledge within the team. So because the team DevOps person is there in DevOps team, from the DevOps team, or the DevOps team and development team is together, they're working together. So the knowledge should keep on sharing within the team, so that they can improve their process of working, right? And last in this part, measure everything so improvement can be done for the better. So why did I say measure everything? So every time you give any test you get marks, and marks motivates you. So that's why you have to measure everything in terms of what went wrong and what you can improve. Okay, so what went wrong and what we can improve. Okay, so this was the theory part. It is little boring also, but understand from the beginning. What is DevOps? DevOps, we have development plus operations. Without DevOps, what we do, we took months, even years. It takes more time to deploy. It is slower, and if there is any mistake, we were blaming each other, right? But DevOps is better in terms of working together, flow, feedbacks, learnings, everything is given in DevOps. So the drawbacks are fulfilled. Now, DevOps itself is a very big process. So in the next part, we'll understand the life cycle of DevOps. Okay. So let me add one more page to it. How can I do it? Page one, duplicate page. Okay, it's not working. Okay, yeah, right. So we have added second page. Up on this page, we will understand the life cycle. Now, life cycle of DevOps. Now the things gets much more interesting in this phase. It is less of theory, but it is something like we do in a DevOps part. It is interesting to know, and DevOps is also, let me see if I have that part. I may not have that search. Find in shapes. Find in shapes. I will find shapes infinity. Do we have infinity here? Infinity search shapes. Yeah, we have infinity. Wow. Okay. So life cycle of DevOps equals to infinity. Why infinity? Because it keeps going on. It repeats itself. That's why we are we use infinity as its tool. Okay, why this? So let me give you the stages in life cycle of. So first stage is I'll give you plan, and the next stage is I'll give you, after plan we have code, plan, code. Next, okay, next we have build, build. Next we have test, and next we have what do we have? Release. Plan, code, build, test. After test, we'll release it. Release. After release, what we will do? We'll deploy. Deploy. After deploying, what we'll do? We'll monitor. After deploy, there is one more thing in between, which is operate. We'll understand each and everything, and after this, we'll do deploy. Deploy. Sorry, deploy is done. Plan, code, build, test, release, deploy, operate, then monitor. At the end we'll monitor. So you see, after monitoring, the one part is done. The second thing, maybe new feature is coming. This is a cycle. Then we'll discuss the new feature, we'll plan it, we'll write the code for it, then we'll build it, build the program, we'll test it. After testing, we'll release the repository. After releasing, we'll deploy it. The working repo will be deployed to the server, or maybe on premises, or maybe on the client side. And then we'll operate. What is this operate means? We'll operate means this is the operation work where we keep our servers up and we scale it to the more servers, right? After that, we'll monitor it, and once it is all working fine, then we plan it again for the next feature or next part of program or website or web application. Okay, so you see here we have a cycle. We have a cycle, so that's why it keeps on going in a loop. It never ends. That's why we also denote, we also show use infinity to show DevOps, right? So this is a continuous cycle. Let me if I have to anything, no, I need not to explain you anything explicitly. You'll learn it in the process. So this part is clear, I think. Plan, code, build, test, release, deploy, operate, monitor. Here we are writing code. Let me, nothing to be given extra here because it is okay. Plan, code, build, test, release. This is the life cycle of DevOps. You can learn it. It is very important, right? Now, now we will move further. What there are, like, what we have done two things, three things till now. We have understood what is DevOps, why DevOps, and life cycle of DevOps. Now, when we have used DevOps, then what are the matrices? How do we check if the development part, whatever we have created and deployed, is working good? What are the measures? So there is one term which is DORA, DevOps Research and Assessment. There are some key uh, features or key processes with what we can identify whether our success rate is high, our DevOps team is working fine. So that's we are going to learn here. So DORA is what? Nothing but it is DevOps, DevOps Research and Assessment. We are assessing whether the deployment and development process is working fine. It is up to the mark or not. Assessment. It's a kind of giving marks, right? So here also there are five things, not five things, four things I remember. One is the deployment frequency. Second thing, lead time for changes. How much time did we take? Third is failure rate. Fourth is how much time do we take to recover from any failure. So these are the four things we have. So let's start with first one, deployment frequency. Frequency, right? So deployment frequency means how soon, like how soon or how much time we are taking uh, to deploy an application. So the best is multiple times a day, multiple times a day. So this is the best part. If we are deploying multiple times a day, this is the best. Okay, but it can be one time or two times a day, or one times in 2 day or 3 day. We deploy frequently also using CICD pipelines, Jenkins, right? So this is good. Next thing, lead time for changes. So for example, we write some code and there is one change we need to do. How much time we are taking? It would be a small change, right? So that change, how much time we are taking. To ideally, we say 1 hour, but it depends. It depends. It depends on what? It depends on the change, because end to end, it is ideal. It never happens that we are deploying any changes in 1 hour. It will at least take one day, because I'm saying you with the experience, because whenever there is any change, minor or major, whatever it is, we'll write the code first, we'll test it locally, we'll test it on staging, we'll give it to the QA, then QA will give us the yes, and we'll update it. There are many tools and processes in between. We are emailing, we are updating the Jira, we do many things in between that. So this process will not cannot be completed in an hour. So it will, if it is a very minor bug, let's say to change the font, right, to handle null, this is very small change. It will also take whole day, because we have to test it end to end. We cannot take any risk, right? So this is ideal, but one day is perfect. Now the next thing, change failure rate. What does this mean? This means how much deployment failure we have. How much deployment failure we have, right? It can be, like, the ideal is 5%. It should not be more than that, like this. So whenever we do the deployment, it should be 95 times out of 100 it should pass, it should not fail. 5% we can handle, this is okay. Okay, last thing, mean time to recovery. Mean time to recovery, what do you mean by this? This means how quickly you can fix the production problem, fix the production issue. How quickly we can fix the production issue, right? So these are the, how do I say, these are the, let me give page 2 for this. Page 2, DevOps. Two, and I'll save it in my device. Save. Okay. Save. Okay, now let's move on. Okay, we have meantime, we did this Dora and everything, right? Okay, so let me recap. Let me give you the recap once again, what we have done, what we have understood till now. So this is all we have on the basic things we have on DevOps. What is DevOps? DevOps is made up of developers and operations, who are admins, who used to create a server, manage a server, they monitor the server, they monitor the logs of the server, whether it is up or down, whether there is something wrong with the server or not, right? Next thing, why DevOps? Because DevOps makes it very easy to deploy, test, build, monitor, and release quickly in terms of time also. So these are the very good benefits of this DevOps engineer. So that's why this was introduced. We have some flow. These are some theory part. You can understand these things. But the very first important thing is this: why DevOps? We need DevOps to uh, build an application quickly, smartly, with less errors, with no errors, smoothly, with with the process, smooth process, smooth deployment, quick monitoring, easy monitoring. These are the some aspects of DevOps, right? Second thing, the life cycle of DevOps. How do we build an application. So if there is any website, we will plan for a feature to build it. We'll not build it completely in one go. We'll code for that. We'll build it. We'll create a jar and var. We'll complete it. We'll check if our code is working or not. Then we'll test it. Then we'll release this. This branch will give it to deploy. Then it will be deployed, and we'll operate it. What is meaning of this operate here? Operate means we'll manage the servers, we'll create servers, we manage the servers, we'll check the servers up and down, right? And then we'll monitor, and after monitoring we'll again go back to the plan part. If there is any issue with that, let's suppose we are monitoring and there is one error comes, so that error needs to be fixed, then it will plan for that error also. And to while planning, we'll write the code and we'll build it again for that error also, right? And we'll test for error, and for new feature we'll do the same thing. So that's the life cycle of DevOps. Let me go little deeper for this also. In planning, we use some tools like Jira, right, to keep track of everything, right? And in code, we can use any language. Like in code, language is different. Like we can I can give you Eclipse is the IDE where we code. Java is the language in which we code, and GitHub is the repository management where we keep our code. That's what we do. And how do we build it? We build it. It can be Maven or Gradle or npm. These are the build tools, right? Now test. How do we test? We do use the JUnit for testing. JUnit testing, we write JUnit test, right? And we write some automation also, automation code using Selenium and Gherkin keyword. Selenium and Gherkin keywords, right? And in release, what we do in releases, we use GitHub Actions and Jenkins CICD pipelines. CICD, we do continuous integration and deployment. We'll learn in detail in future about these, but for now I'm giving you some more insight about this. Deploy, we deploy where we can deploy. We can deploy on Docker, Kubernetes, and we can deploy on any server also, right? These are the tools, deployment tools. Kubernetes, right? Next, operate. We have to operate management. We have Kubernetes, Terraform. In Terraform, what we do, we manage multiple servers to upload. Basically, more than one server to manage and maintain. We use Kubernetes and Docker and Terraform. There is one more thing, Ansible also. So they will work together. These all tools will work together. Like monitor. In monitoring, what we do, we have logging, like Grafana, Prometheus, logging. Okay, so that's all we have. Thank you guys.